Alright guys, so we're going to talk about z-scores. A z-score is how many standard deviations, that's our sigma. An element is above, that's going to be positive, or below, so negative, the mean. Remember, when we're talking about z-scores and we're looking at our formula sheet, we call the mean mu, but our calculator is going to call it x bar. So the formula for z-score is z equals x, our element, minus the mean, or x bar, over our standard deviation, our sigma. And the z-score is basically going to tell us if we had a perfect curve of our data where where our standard deviations would fall. So here, one standard deviation above the mean is actually 8.53. That's one standard deviation. And one standard deviation below the mean is right here at 5.65. And I found that because it was given to me that my mean was 7.9 and my standard deviation was 1.44. So again, we can see that 7.9 plus 1.44 is 8.53, and 7.09 minus 1.44 is 5.65. So it's going to ask us, what is the z-score of a shoe size 9? Well, 9 is our element, so we're going to take our element minus our mean over our standard deviation. 9 is our element, so 9 minus our mean, 7.09, divided by our standard deviation, 1.44. That's our z-score. We simply do the math there and we end up with 1.33. So we can say shoe size 9 is 1.33 standard deviations above the mean. Next, we're going to look at the question, what shoe size has a z-score of negative 1.24? Negative 1.24, we know it's going to be below the mean. So our answer is going to be less than 7.09. So we take our z-score 2.14, and that is equal to our element, the shoe size we don't know, minus our mean, 7.09, divided by 1.44. This is just a simple two-step equation. We multiply right here. 1.44 times negative 2.14 is going to equal x minus 7.09. Negative 3.08 equals x minus 7.09. Add 7.09 to both sides. And 4 equals our x. So shoe size 4 has the z-score of negative 2.14. Remember, if you need to watch this again, you can go ahead and rewind it and do so. And be sure to check out the other videos on MAD and standard deviation if you're confused on those.